Hello, my name is Scott Bannister, based at the University of Leeds, and I'm happy to share recent research on the perceptions of lyric intelligibility in music by hearing aid users, carried out as part of the Cadenza project. Hearing loss is nationally and globally prevalent, with previous research, including the Hearing Aids for Music project, demonstrating that hearing loss can create perceptual issues with music engagement, such as reduced frequency selectivity, pitch perception difficulties, hearing out individual instruments, and hearing lyrics in music. Importantly, hearing aid technology can help with manufacturers developing specific programs or settings for music. However, overall hearing aids are primarily designed for speech and can still introduce problems for music signals, such as distortion or feedback, and dynamics issues ranging from inaudibility to excessive loudness. Building on this research, the Cadenza project is a multi-institutional project aiming to develop novel signal processing strategies to improve music listening for people with a hearing loss. In Cadenza, there are two overarching streams of work. The first involves designing and running public machine learning challenges to improve the processing of music for listeners with hearing loss. The second involves research to understand perceptual experiences of music from the perspective of hearing loss and to develop meaningful measurement methods for outputs of the machine learning challenges. So far in Cadenza, we have completed the first machine learning challenge focusing on music audio quality, but for this presentation, it is the second machine learning challenge that is the focus. The task for entrants is to improve lyric intelligibility in music for a listener with hearing loss, listening to music unaided through headphones. Critically, entrants also need to preserve the audio quality of the music. In other words, it is not as simple as isolating the vocals and lyrics and getting rid of the music altogether. To give a sense of how this second machine learning challenge might work, I provide a baseline schematic here. First, the scene generator in the blue box selects a stereo music signal and gives an alpha value of between 0 and 1 that sets a desired target balance between lyric intelligibility and music audio quality. Then, the music enhancement in the pink box takes the music as input and attempts to improve lyric intelligibility. Listener characteristics in the green oval are audiograms and compressor settings to allow personalized processing in the enhancement stage. Finally, the enhancement outputs are evaluated using objective metrics in the orange boxes, in which the processed music signal is compared to the original or reference stereo music. Here there is a metric based on whisper for lyric intelligibility, and for audio quality there is the hearing aid audio quality index. Scores from these evaluations are combined with a weighting corresponding with the generated alpha value. Challenge entrants are tasked with improving what happens in the music enhancer pink box. Critically, however, this schematic only captures the objective evaluation of systems, but we also want subjective evaluations of entrant models by people with a hearing loss. These people form a listener panel that manually rate processed music signals on a series of perceptual attributes. So the remainder of this talk will focus on qualitative work that aims to develop a lyric intelligibility perceptual attribute for these purposes. Broadly, there have been some studies in the perception of lyrics in music with one conclusion suggesting that sung lyrics can often be unintelligible. Importantly, there are various factors that can influence lyric intelligibility. These can be music related, performer related, listener related, and environment related. In terms of genres, work by Condit, Schultz and Huron investigated lyric intelligibility across various musical styles, with results suggesting that intelligibility was highest for jazz and lowest for classical music. Other researchers analysed music audio signals in relation to lyric intelligibility, suggesting a possible importance of mel frequency cepstrum coefficients and syllable rate in the singing. Overall, however, there are few studies on lyric intelligibility perception for listeners with a hearing loss. So there was a need for further research to inform understanding of lyric intelligibility perception and to develop an attribute to subjectively evaluate machine learning systems in the second Cadenza challenge. This is what we aim to achieve through a focus group study. Critically, the aim was for this lyric intelligibility attribute to be listener driven and developed inductively by a group of hearing aid users. As researchers, we are only there to facilitate and support. It is the participants who work together to develop the definitions and the measurements. So in this study, 10 hearing aid users took part with hearing loss severities ranging from mild to moderately severe. The study itself was comprised of three main stages. First, there was an online listening task for participants to engage with short music samples and respond to questions about lyrics. However, the focus of this talk is on the two subsequent online focus groups. The first aims to develop a group understanding and definition of lyric intelligibility using music samples to illustrate key discussion points. And the second focus group then aimed to focus on developing measurement methods for capturing perceptions of lyric intelligibility as defined by the participants. So in the first focus group, there was detailed discussion around the factors that can affect lyric intelligibility, which include familiarity with the music and associated memories, and how, for example, familiarity can help with following the lyrics in some cases. Another factor was genre and how lyric intelligibility perception differs across styles. A further consideration was the performance of the singer, and finally the idea of balance was discussed by participants, such as between the singer and the rest of the accompaniment. Another interesting discussion was around distinctions between the lyrics and the singing voice. One key conclusion from participants was that the singing voice can itself be clear, but the lyrics remain difficult to understand. An example of this would be in opera singers. The singing can be exceptionally clear, but the words or lyrics remain difficult to pick out due to the singing style. In continued discussions in the second focus group, there were some quite tricky aspects of lyric intelligibility being navigated. The first relates to audibility versus understanding. Participants concluded that lyric intelligibility is more about being able to hear what is said, rather than understanding what is said. An example scenario here is listening to music in an unknown language. The lyrics might be clearly heard, but understanding might not necessarily be there. The second discussion was around lyric intelligibility and audio quality of the rest of the music. Participants felt that these aspects were correlated with an indicative quote included here on the slide. But participants also acknowledged that there is some degree of dissociation. For example, imagine that one solution to maximise lyric intelligibility is to remove the accompaniment altogether. That's great for perceiving lyrics, but the audio quality of the music is very poor as a consequence. In concluding such complex discussions, participants felt that the impact of reduced lyric intelligibility or music audio quality differs depending on various aspects. So ideally, a listener would want maximal lyric intelligibility and audio quality, but the impacts of not having this may be greater in some listening circumstances compared to others. All of these discussions contributed to the endpoint of the study and development of a listener-driven lyric intelligibility definition. This emphasises some key details, such as being able to clearly and effortlessly hear the words in the music, good versus poor lyric intelligibility, which I highlight on the slide here, and the influence of various factors on lyric intelligibility. Participants also felt that a scale from 1 to 100 would be an intuitive way of evaluating this attribute moving forward. To summarise, lyric intelligibility in music is related to musical style and genre, balance in composition or production, individual differences of listeners, and the singing performance. These findings align with broader and previous research. An interesting result was the distinction between lyric intelligibility and lyric understanding, which may reflect some ideas in speech perception on comprehensibility versus intelligibility. Participants felt that lyric intelligibility and music audio quality should both be maximised, although a loss of either attribute may have varied impacts across different listening experiences. A final key outcome of this study is a working definition and rating scale for lyric intelligibility, which we have since taken forward to subjectively evaluate machine learning systems in the second Cadenza challenge, data of which are currently being analysed. Thank you very much for listening.